Part 4 for exercises 13 to 21, write the definition, property, postulate, or theorem that justifies each statement. So in 13, if 2 times the measure angle 1 is 180, then measure angle 1 is equal to 90. So you definitely want to go ahead and take a look at your pink sheets, okay? That's how you're going to answer these questions. So if I say, if 2 times the measure angle is equal to 180, then measure angle 1 is equal to 90. So I'm going from here to here. What happened? Well, I'm dividing both sides by 2. So that's just going to give me measure angle 1. So 2 times the measure angle 1 divided by 2 is the measure angle 1. And then 180 divided by 2 is 90. So this process here is called the division property of equality. Okay. And then here, number 14 is if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So it's like saying this. So if A equals B and B equals C, therefore A is equal to C, right? That's what we call the transitive property. That's what we call the transitive property. So I can just say, let's cross these out, and then you get this congruent to this. So there you have it, right? So this is the transitive property. Next, if AB is equal to CD, then CD is equal to AB. And these two measures are being swapped, right? The positions are being swapped. So now CD is on the left-hand side and AB is on the right-hand side. Going back to our pink sheet, that is what we call the symmetric property. So that's the symmetric property. If 2x minus 4 is equal to 16, then 2x is equal to 20. So looks like an algebra problem to me. So I'm going to add 4 on both sides. So therefore I get what? I get 2x is equal to 16 plus 4 is 20. That's the addition property of equality. Okay, so here, me adding 4 on both sides, that means I'm using the addition property of equality there. If two angles add up to 90 degrees and they are complementary angles, okay, so this seems like the definition of complementary angles. If 2 angles sum up to 90 degrees, then they are complementary angles. So that's definition of complementary angles. If measure angle B is equal to measure angle C, then angle B is congruent to angle C. So notice that I have a B here and a B here and a C here and a C here, and this is using measure, and this is just simply angle. This here is using measure, and this is just simply using angle. And then one more thing, that's an equal sign, that's the congruent mark. So here I can see that I'm dealing with values, and then it's being translated to geometry, which I'm naming things. So length / values to shapes, naming, and etc. Right? That's the definition of congruence. And if I wasn't clear enough, this right here is the language of algebra, and then right here is the language of geometry. I'm basically converting from algebra to geometry, so it's a definition of congruence. Now, if it says if angle A, or if angle B is congruent to angle C, then measure angle B is equal to measure angle C. You're going from the language of geometry to the language of algebra. It's still a definition. It goes both ways, so it works. Okay. Number 19, segment AB is congruent to segment AB. This is just a mirror, right? So it's basically a reflection. So if I go back to my pink sheets, by the way, here is definition of congruence. Over here, this is that problem would be the reflexive property A equals A. Segment DE is congruent to segment DE. That's what I want. So this is the reflexive property. Okay. If point J is between point L and point M, then LJ plus JM is equal to LM. Okay, so I'm gonna go ahead and draw this, and then I'm gonna see if it gives me this. So you have L and M, and J is between those 2 points. So you have a part. That's a weird bracket. You have a part plus part is equal to a whole. So LJ, yes, that's LJ. That's JM, and then this is the whole thing, LM. All right, that's LM. So this is what we call the segment addition postulate. Segment addition postulate. Okay. Lastly, number 21, if X is the midpoint of segment ZW, then segment ZX is congruent to segment XW. So ignore this. We want to see this, right? This is so important. When you're doing proofs, you got to understand your definitions. So if you have segment ZW here and X is the midpoint, so if X is the midpoint, y'all, what happens to the segment? It's going to split the segment into 2 congruent parts. So this and this are congruent. So now I can see that segment ZX is congruent to segment XW. So that's going to lead me to this. Okay, that's the result. So what's the definition here? Definition of midpoint, it splits the segment into 2 congruent parts. Therefore, segment ZX is congruent to segment XW. So I can write that down.